In this video, we are going to be discussing what are known as torque moments. So if you remember, a moment is a tendency of rotation. A torque moment, more specifically, is a tendency of rotation of a member's cross-section. Okay, so we're going to say this is the tendency of a member's cross section to rotate. Okay, so for example, let's look at an illustration to kind of visualize this. Let's say that we have I'm going to draw a 3D view real quick. Let's say that we have this beam kind of like this. And I'm going to try to make this a rectangular beam. Okay. And let's say that back here it's fixed to a wall. Okay. And let's say that we have this force acting on the beam at its corner. Okay. Force right here. All right. Now, again, notice that I drew this force acting at the corner of the beam right here. All right. Now, when I have this, this is a 3D view, by the way. When I have this force acting at the corner of the beam, let's look at a cross-section view or a front view maybe, and see what this looks like. So if we looked at a front view, we're going to see the front of the beam right here, okay, kind of a square shape, and here is the force right here. So what's going to happen to the cross section, right? What's going to happen to what's happening in the cross section of this beam? Well, this beam is going to tend to want to twist kind of like this, since this force is at some kind of distance away from the center of the beam, okay? So this cross section of the beam will tend to want to like rotate kind of like this and twist about the center point, all right? So the question then becomes, what is this torque moment that is produced, all right? So what happens is we can develop T is torque moment, and that's going to be equal to that force times something. Well, that something is still a perpendicular distance. But what is the perpendicular distance in this case? Well, the perpendicular distance is the distance from the point of action of the force to the center of the cross section right here, okay? So if this beam has a width of, say, B right here, then this torque is going to be equal to force times B over 2, right? Because in this view right here, here is B, this is the total width B, but the center of that cross-section is at B over 2. So that's the tendency of rotation of this cross-section, okay? So let's look at another illustration, or maybe more of an example. We'll call it an example. I want us to compute the torque moment developed. All right, so let's say that we have a member cross-section right here, and let's say that this is a circle with a diameter of 6 inches. Maybe it's some kind of pipe, whatever. It's some kind of something with a circular cross-section. And let's say that you have a force applied at the edge of this member cross-section, okay? And this force, let's say it's 10 pounds, all right? So what would the torque be that develops here? Well, again, we can draw something like this, that is developing right here in this cross section. It's causing, this torque is causing the cross section to want to twist. So what is that equal to? Well, that's going to be equal to the force, which is 10 pounds, times what? Times 6 inches? No, times the distance to the center of the shape, which would be 3 inches. So this would be 30 pound-inches of torque that's developed in this cross section due to this applied force at some perpendicular distance away. So again, notice the definition here. It's a perpendicular distance. What we mean is the distance right here is perpendicular to where the force is acting. And we can even see that up here in this rectangular beam, right? The distance b over 2 that we're interested in is perpendicular to where the force is being applied, okay? So this is the idea of a torque moment. Again, it is a tendency of rotation or a tendency of twisting of a cross section of a member. And in this little numerical example, the member that I drew had maybe a circular cross section with a load applied at the edge right here, okay? And so when you're looking at torque moments, you're often multiplying that applied force by the distance to the center of that cross section.